Dear friends and students, a very good question is here, and the question is related to chemical kinetics. Of course, it is a PYQ, and that's why it is very important also. And the question is related to what is known as Arrhenius equation. We know that Arrhenius equation is given as K is equal to A E exponent minus EA by RT, where A is the frequency factor, EA is the activation energy, R is the gas constant, and T is the temperature in Kelvin. And the question calls for another equation, that is T half. T half is equal to ln 2 divided by K. And when we solve it, we know it that we get equal to T half equal to 0.693 upon K. So the question which would be coming to us is nothing but a combination of Arrhenius equation and also the half-life period. And you can very easily make out it might be a first-order reaction. So let us go through the question. The question is here. The question says, a molecule A changes into its isomeric form B by following a first-order kinetics at a temperature of 1000 Kelvin. If the energy barrier with respect to reactant energy for such isomeric transformation is 191.48 kJ per mole and the frequency factor is 10 to the power 20, the time required for 50% molecules of A to become B is, of course, a blank space is there, and we have to find out the time required here in picosecond and convert it into the nearest integer. The value of R is also provided here. So this question provides sufficient hint about how to solve it. The steps required for solving can be very easily made out by going through the question again. And we find a number of options are given, and we have to find out the correct answer out of all these four options. And as we look here again, we find it is a first order reaction. Definitely, this is one hint. The other hint is that the frequency factor is given as 10 to the power 20. And finally, one more hint is provided that the time required for 50% molecules of A to become B, that means we need to calculate the half-life period. There is the relation with the half-life period and also the first order reaction. And since the frequency factor is there, we can very easily make out that this has got to do something with Arrhenius equation. So let us go through the question and answer it stepwise. Firstly, it can be attempted in a number of steps using different steps. And if you look at the given data, we find the frequency factor is A given as 10 to the power 20. Activation energy is also given. Gas constant is known to us, and the temperature in Kelvin is also provided here. Now we will take up calculations in different steps. First, we shall find out the factor EA upon RT, because that is an exponent of E. So if you put up the values here, given values, we get that EA upon RT is approximately equal to 23.031. And then we again put K is equal to A is given 10 to the power 20, E and EA upon RT we have calculated here. We substitute the values and we get the rate constant K, first order rate constant, of course, is equal to 10 to the power 10 second inverse. And then half-life period is to be calculated. This formula is to be substituted here, T half is equal to ln upon 2, or you can say that T half is equal to 0.693 upon 10 to the power 10, because now we know K. We put up the values here and we get the T half as 6.86 into 10 to the power minus 11 seconds. Okay, then we need to convert it into picosecond. The conversion factor, we have to recall that 1 second is equal to 10 to the power 12 picosecond. Put up the values, and when we convert it, we get, putting up the values, we get the answer, final answer as 68.6, which when you round it up matches with option 1 of the question, and therefore this option 1 is the correct answer here. Okay, thank you. That is how this has given us an idea. Question is very important, and it has given us an idea how to combine the Arrhenius factor and the half-life period in a first order reaction. Similar questions might be applicable in another way in different competitive examination, and therefore it has to be taken all care and solved properly. Thank you again. Please do subscribe to our channel to get more such questions and related texts. Thank you again.